Hello and welcome to another video on Numpy. And we would once again demonstrate how broadcasting works. So using this particular example, we are given a track strip of 50-meter radius. We're talking about the radius of this strip, the circular track rather. We're talking about a radius of 50 meters. And we need to design about 8 different lanes over here. So let's try and understand what we're doing. Basically we're assuming a circular track, right? And this is about 50 meters. This is our radius. So we're basically going to design concentric circles such that you basically have about 8 of these. The circle is too small, but we're going to have a few more so that when we're talking about athletes starting at a certain point, they do not all start at the same point because they're not running the same distance, right? It won't quite be fair because in terms of radius, say you had to complete one round. Okay, the equivalent of one round for this one would be a lot shorter than one round for this person. Okay, so you get a starting point that compensates for that. This one probably begins over here, that athlete. So we're going to find out what would be the difference between the running distance of each lane. All right. So we start by beginning. We'll need to import our library to begin with. Import numpy as np. And we can create an array using arange for each of the 8 lanes. We're talking about 1 to 8. So we'll go 1 to 9 in arange. That's our array. And given we are talking about 50 meters, right? So we have the radius of array 1 would be 50. Say each of them is 1 meter. We're assuming the width of each lane is about 1 meter. So we'd have 50 minus array 1. And we'll have to give a gap of about 2 meters from the outside, right? You don't want to start right at the edge of the track. So we'd say 50 minus 2 minus array 1 plus 0.5, right? Just to get to the center of each lane, we're talking about going to 0.5, adding 0.5 to get the distance to the center of each of these lanes. So that would be our radius array 1. There you go. That would be the radius of each lane, such that if one particular athlete was running the entire length, we would have run distance given by radius array 1 multiplied by twice of pi, right? We're talking about the circumference of each circle. So 2 times. We can use it from numpy, np.py. This would be the run distance. Let's take a look at what our array looks like. There we go. You can now see how each athlete in each of the concentric lanes will be running a completely different distance. The one in the innermost will have a lot less, around 44 meters less than what the person in the outermost lane is running. So to make up for that, say our actual event, if a particular event is talking about running 200 meters, okay, we have a sprint event of 200 meters. In that case, our starting point for each of these, assuming the first one starts off, you can kind of assume a single starting point over here. And to go all the way, the first one is covering 254. So that's not what we want. We just want him to start around at this point, right? What would be those distances? We'll be looking at subtracting 200 from our run distance. Start point as part of your design would be run distance minus 200. Notice how we are doing broadcasting for the array each time we are performing a certain operation. So that's your start point for each and every lane given by these values.